So good morning, everybody. Welcome to our new ESA webinar, Unlocking Proactive Maintenance with Predictive AI Solutions. This webinar is offered by ESA member Symphony AI, based in India, but already very much involved on global level with lots of international business and very active already also in Europe. So before we start, I would like to start first with the housekeeping. So, you know, we like to have interactive sessions, but we would like you to come with your questions at the end of the presentation. And then when you come with your questions, make sure that you are in a silent room, that there is no noise, that your mobile phone are in silent mode. And please mute your microphone if you are not speaking. And then, as I said, after the presentation of Webav, we'll be happy to have an active session with all of your questions and so on. So that's what I would like to say before we start. Some of you are not yet ESA members, and please consider to do so, because we are the largest and by far professional association dedicated to companies who are repairing and maintaining rotating machines, systems, and then electric motors also, and generators, by the way. We have 1,800 service companies who are member of our network, and lots of OEMs, but also suppliers and so on. So these are, let's say, the fantastic network you will have access to if you join ESA. And very quickly about all the benefits we offer to our members, from 6 permanent experts available for any kind of questions, training. We have a huge database and knowledge base with lots of reports, manual, but also data to, let's say, maintain motor systems. We're active in standard bodies. We are working with our members on various projects. We have an ESA accreditation, and we then also offer, let's say, lots of events and congress, and I'm going to give you a little bit more details. But you see that this is a very active network, and if you are not yet an ESA member, please contact me. I will be happy to help you to do so. So end of this week, we will be in Las Vegas. It's, I think, by far the biggest event in the world dedicated to motor maintenance and repair. We expect 2,500 participants during 3 days, from the 23rd to the 26th of June in Las Vegas city, in the Arras Hotel. It's still possible to register if you have not done it. And then in the coming months, we will be also with our members in Europe, Asia, and Africa, in Porto, Portugal, from the 3rd to the 5th of October. Every year we have more and more participants. And last year we were 150. This year we are dreaming to be a little bit below than 200, but that's also an important benefit of ESA. And then this year, we're happy because one of the largest company to produce and distribute electricity in the world, EDF, that I'm sure many of you knows, have offered to host a French Congress in Paris from the 27th to the 28th of November. And again, in the coming days, we'll start to communicate about this important Congress. Just very quickly, because you know that the limit we have now in terms of business is about, let's say, people. So, and well-trained people. So ESA is very serious about training, and these are all the training to come in the next months, is specialized training for our industry, with manuals that are almost considered like standards and reference for, by the way, many top OEMs also. This is just, let's say, about me, and I'm the General Manager of ESA in Europe, Asia, and Africa. And if you want to contact me, because that's what I mentioned, for the ones who are not yet member, you have my contact here in that slide. I'd like to conclude my presentation with our important slogan that really summarizes what are we trying to achieve in ESA, stronger together, shaping the future. So Vaibhav, I'm going now to stop sharing my screen, and I propose that you start sharing your screen, and please go ahead with your very interesting presentation. Thank you.
Thank you, Frederick. I hope you can see my screen here.
Yes.
Okay. So,
and just before you start, Vaibhav, I just want to remind that maybe we don't see yet, but it's already 28 participants who are now online. But we have 90 people who have registered for this webinar from 32 countries and 75 companies. So quite an interesting number of participants. Vaibhav,
okay.
Sorry, please go ahead.
No, good to know. We have a good number of participants here. So, hello everyone. Good morning. I am Vaibhav. Welcome to today's webinar on unlocking the proactive maintenance with predictive AI solutions. In next 30 minutes, I will take you through what is the proactive maintenance with predictive and generative AI. What does it mean? How it is different from your conventional predictive maintenance? We will look at some of the real-time, real-world use cases where we have implemented our solution, how it helped our customers. I will show you also a quick demo of our predictive asset intelligence application, and we will wrap up this session with questions and answers at the end. So let's start with a quick introduction of the company. So Symphony AI is a leading enterprise AI SaaS company, which is producing AI products across 5 key verticals, including retail and CPG, financial services, industrial, media, and enterprise IT. The vision of Symphony AI is to accelerate revenue growth and boost business productivity through our generative and predictive AI solutions for our customers. For us in the industrial domain, this means to provide you offerings that can accelerate your ability to access industrial data at scale and map the data across people, process, and assets in order for you to drive site level excellence at scale. We are a global ISV partner for Microsoft, and you can see some of our recent industry accolades from Verdantix, Frost and Sullivan, and so on. We have a presence all over the world with offices in many countries and employees, more than 2,400 employees who have experience in deep experience in different industrial domain like oil and gas, semiconductor, as utilities, assembly, mining and metals, and many more. So a quick introduction about myself. I'm Vaibhav Nadkarni. I'm Senior Product Manager at Symphony AI. I have over 19 years experience in which I have been with Symphony AI for 2 years, and prior to Symphony, I was with GE for 17 years, where I was a global technical leader for technology and product development in gas turbine combustion division. Uh, I have a background in data science and artificial intelligence, and I have experience of implementing Industry 4.0 applications in energy, transportation, and oil and gas domain mainly. So with that, let's look at today's topic. So in the next few slides, I'm going to talk about what is proactive maintenance, how predictive AI can be a key enabler for proactive maintenance, and how Symphony AI products implement this methodology. Now, I believe most of you are familiar with this graph of machine condition versus time and how the maintenance strategies are categorized based on when the action is taken. Now, in the conventional predictive maintenance strategy, this strategy mostly rely on measuring the vibration data from our rotating assets and analyzing it to predict impending issues with the impending issues in the machine. In this approach, process data is also sometimes monitored, but monitoring is usually done with a rule-based approach. That is the user will get an alarm or an alert only when the value of that parameter crosses certain threshold. Now, one of the drawback of this approach is that most of the time the process and vibration data is analyzed in isolation, because it is not possible humanly to analyze hundreds of sensor data altogether. This means that sometimes user gets alert which very close to the actual failure, and they do not have enough time to react. And also, also because process and vibration data interaction is not considered like together, the fault coverage often remains limited. So this is where the the proactive maintenance with predictive AI comes into picture. So predictive AI enable user to combine the process and vibration data in real time, analyze the data in real time, and then gather comprehensive actionable insight much in advance before any failure begins. And this is only possible with predictive AI models, which can analyze thousands of sensors data in real time very quickly. Uh, Moving on. So now this slide talks about how Symphony AI proactive maintenance, we implement the proactive maintenance methodology here. So our application is predictive asset intelligence, which combine high frequency vibration with the process data in real time to give you the alerts and alarms much before the failure begins. So in this case, we take different both structured and unstructured data from an asset from sensors. So we use unstructured data, for example, like oil sample reports or vibration reports, which comes in regular intervals. We also combine process data, which is coming in the real time from various sensors installed on an asset. We also take vibration data into picture and combine with all this information which is coming from an asset. Now, all this data is then used to create what we call asset hierarchy in our application. The asset hierarchy is nothing but a digital representation of your asset. It will have these in the application, you will have those channels which will kind of mimic each sensor on your each sensor which is installed on your actual physical asset. So that sensor data will be mapped onto those channels. And then once the mapping is done, the data is coming into this application. An anomaly detection engine runs AI algorithm in real time on this data. It is not just one algorithm. We run many algorithms in parallel and select the best out of it to detect the anomalous behavior of the machine. Now, how it is different from many other products in the market is that we do not rely on pattern recognition to detect the fault. What does it mean? That we don't need we don't need to know the pattern of parameters or the trends of parameters when failure occurred in the past. All we need from you is a good 2 months, 3 months historical data of your asset when it is running in good condition. And then we train the models on that good data. And then this AI algorithms basically then calculates what is called as anomaly score on the real-time data. And this anomaly score is nothing but it's a parameter which tells the algorithm that how far your machine is running, how far your machine is running from a normal behavior. And if it detects that some parameters or many parameters of the your data is deviating from the normal behavior, it looks into that. It combines that deviation with a digital FMEA which we prepare, and with based on that, it provides an alert. And not only it provides an alert, it also tells you what is the cause of that an alert, and what are the recommendations or what are the actions that you should take to mitigate that issue. In this way, it does not remain a black box anymore. So that's the a good point of USP of our predictive asset intelligence. Now to bring now in market whatever applications are there, many times we hear from customers that the time to value is very long. The project takes, or POC takes a long time to to build and to generate a value. So to expedite that process, to bring rapid time to value to customer, we have created a library of different assets, most commonly occurring assets in the industry, which include these rotary assets like centrifugal pumps and compressors, turbines, including gas turbines, steam turbines, reciprocating engines, motors. We also have static assets like heat exchangers, furnace, separators, and columns, and so on. For all these assets, we already have built the failure mode and effect analysis. If you do not see your particular asset here, we can build for one for you very quickly. We can also collaborate with your SME, subject matter expert, to improve the existing FMES according to your needs. So with the help of this asset FMES or asset templates, now we can build a quick the digital representation of your asset very quickly, and bring quick rapid time to value for you. Now, in addition to the predictive AI algorithms that we implement to detect the failures or to detect alerts, we have also developed co-pilots which are powered by Symphony AI Industrial LLM. And these co-pilots are persona based to enhance the decision making using generative AI. There are three type of co-pilots, but for purpose of our webinar here, we have developed a co-pilot for plant performance personnel, for example, a reliability manager or a maintenance engineer. And this co-pilot then can assist them to make decisions, to troubleshoot an alert, to perform a root cause analysis, to do a comparative analysis between different assets. So you have a pump there, you have, let's say, 5 pumps in a plant, and you want to compare their performance. You can use this co-pilot to compare their performance, see everything on one screen. You can also now most of the time these large language models do not have capability to they only respond to prompts, and they do not have capability to really forecast trends or plot parameters and so on. But we have also integrated our predictive AI models with Copilot to bring you the capability to uh, plot the parameter of interest on demand in Copilot. You can also create, you can also trend the forecast of that particular parameter over next few hours or few days, and so on. So so this is our capability in brief. I want to spend more time on demo later. So all these capabilities you will see in the demo. But before we move on to demo, I would like to take you through a few use cases. These are real-time use cases from our existing customers, where we have implemented these solutions to
Are they
bring them.
successful with the end users for new projects?
Yes.
Okay.
Yeah. So these are
I was a little bit okay. So they are basically our channel service provider type of. It's not, yeah. At the same time, it's like okay, makes sense now. All what you wrote.
Shall I continue?
Yes, ma'am.
Yes, please.
Thank you.
Okay. All right, so this is the use case first use case from one of our customer who is a large industrial gas producer in Europe. They have multiple plants across the world, and they had a problem of unplanned downtime events, and they did not have visibility into all aspects of their machine health, which was affecting their bottom line. So they approached us, and we implemented this predictive asset intelligence solution for many of their critical assets. And this particular example is from water air cooled motor for compressor. Now, in this particular case, what happened that an air ingress happened due to water valve malfunctioning, and this air was trapped at the highest point in the system, and it was causing the winding temperature of the motor to go up. Now, if it was not controlled, it would have caused a trip in the plant. But with our predictive asset intelligence, we were able to give them alert 4 days in advance of the event. So you can see here, this is the plot of an anomaly score. And you can see the red is where, it is the machine is deviating from its normal behavior. But you can see see some red color here on this anomaly score, which means that anomalies were started showing some signs of increasing pretty early, like 4 days in advance from when the real event happened. So we gave them this alert with cause and recommendations. And because of this alert, they were ready to take the action. And they took the action, and they were able to mitigate. They were able to basically mitigate the unplanned downtime here. Now, a little bit more details here on this plot. You can see that these are all, motor, non-drive end and drive end bearing temperatures and cooling air temperatures. So the real event happened here, where when the temperatures shot up, but you see there were signs much earlier, and this might or might not have been captured through a normal use-based approach, because that will depend on what rules you set, what kind of threshold you set. But here in this case, this AI model was able to clearly sense this anomalous behavior, and it was able to raise an alert 4 days in advance to prevent an unplanned shutdown. So that was on industrial gases side. There is one more use case on the power generation side. So this is our customer is one of the large US energy producer with 9 plants and producing total of 12 gigawatts. And here we have implemented our predictive asset intelligence solution on 150 assets over 9 plants, which include large boiler feed pumps, turbines, motors, and so on. And in this particular case, this our solution was able to predict the bearing failure for a boiler feed pump almost 3 months in advance. So it started giving the alert 3 months in advance about an impending issue with this boiler feed pump. Customer took preventive action to do the repair and maintenance, and it has saved about 330,000 in lost production and maintenance cost for this particular case. One more before I move on to the demo. So this is another existing customer in US who are aluminum, who manufacture aluminum sheets. And this particular use case was about aluminum rolling mills, where we predicted the issue with the gear much in advance. And when the gearbox was inspected, they found the spalling in the shaft. And we were able to alert the customer about it. And with their preventive actions, they were able to save almost 500K in again, the lost production and maintenance cost. So all these examples are just few of the many successes that we have seen with our customers with this solution. But important point to note here is that in this case, the AI model use both your process data and your vibration data together. It runs algorithms, it detects anomaly, and when the anomaly comes, then it infuses that with the digital FMEAs, which kind of contains the domain knowledge of that asset. It infuses that with FMEA, and it gives you an alert or alarm. And not only that, but it also tells you what was the potential cause and what actions you should take to mitigate that. Now, all this explanation will fall short without a practical demo. So I will show you a demo in which you will see how predictive asset intelligence to get right info to right people at right time, how it can cater to the need of multiple personas in the plant. You will also see how output of the predictive AI model is enriched with industry-specific domain knowledge in the form of FMEAs to produce actionable insights, and how generative AI-powered Copilot significantly lower the barrier to engage with the application, to investigate alert, to collect information, to prepare reports, and so on. You will also get a peek into the knowledge graph, which is a visual representation of the foundation on which the solution run. And at the end, if time permits, you will also see how we can create the asset structure for your physical assets automatically at scale using PNID ingester. Without further ado, let's dive into the application and see it in action. So let me quickly share my screen again. I'm sorry. Yeah. All right. So this is the predictive main page of our predictive asset intelligence application, which is designed to cater to the requirements of multiple personas in the plant. For example, this is the main page of application which is meant for a regional manager or an operations head of company. Here they can see the health score of all the plants at enterprise level. They can see a health score or trend here along with the critical assets and some alerts from the different plants which belongs to that particular enterprise. From here we can drill down to any one of the plant to see how that plant is performing, how it is health score, and so on. In fact, one can drill down to each level of asset hierarchy here to according to the need of that persona. Each level of hierarchy here has its own configurable dashboard with various widgets which themselves are configurable and are built for industrial use cases. So you can see, for example, here this is the health score of a boiler feed pump. You can also see some asset documents you can attach here. You can see a performance curve. You can also attach some vibration reports. You can attach some oil reports for anyone to see on this dashboard. You on this side, you also see what are the alerts. This is alert summary of different level of alerts on this particular pump. Now, so let's take a deep dive into what is this health score. So this health score is like it's like a stock index. It's a combination of various components of your asset health. These components could be indicator of mechanical condition of the asset, such as vibration level, oil purity, or the amount of wear and tear. But they could also be derived from first principle models or machine learning models. And combination of all these component is flexible and entirely up to the end user. So here, for example, we are giving 60% weightage to the oil analysis and maybe 40% weightage to the vibration health. You can change this combination. You can add more components to it to get a holistic view of the health of this particular asset. This type of index we can build for each asset of this hierarchy, and it can roll up to higher level to give you the health score for a plant or a system and so on. Now, another important aspect of our predictive asset intelligence application is its ability to receive alerts and alarms when there is an impending issue to be mitigated. For example, here we see an alert or an anomaly is detected on this boiler feed pump, and you can go into the details of this from here. Now, while such an early warning is useful, however, for an alert to be really actionable, there has to be some way to determine the cause and recommendation of issue or the actions to be taken to mitigate this problem. Now, our application does that autonomously by combining the output of these AI models with FMEAs to provide explainability for each and every alert. In addition to, so you can see here, for this alert, the cause is that there is a drive and temperature, bearing temperature is going up, and then recommendation is to maybe monitor it, inspect the bearing if abnormal. You can add more recommendations by expanding the FMES to include more recommendations and more causes. In addition to providing this cause and recommendation for alert, it also gives user all the features to assign this alert to their team members to, let's say, investigate. They can write comments here. They can see history of the alert. They can attach reports, or they can attach the pictures from the field or any other reports here, maintenance logs here to conclude the investigation of this particular alert. Now, this predictive asset intelligence, as I said in the beginning, it is designed to cater to the need of multiple personas in the plant. What we have seen so far is the use for a, say, a maintenance engineer, or for a plant manager, or a reliability manager. But it also provides tools for a subject matter expert or a data scientist to dig deeper into the AI model output, to ensure that no one is running a black box that is not explainable or not trustworthy. Here one can see how this app provide an interface to interact with the factors that are contributing to this particular alert. So in this case, this particular alert, these are the contributing factors for this alert, and you can see in what proportion they are contributing to the alert. User can click on this. User can see how that particular sensor data is trending. They can zoom in or zoom out to do more to analyze the data more, and so on. Now, to achieve the explainability, each point of this anomaly detection engine comes with a set of contributing factors. So as I said in the beginning, the AI algorithm runs continuously in real time on the data, and it generates the anomaly score for every data point that is received from the sensors. And for each data point, you click on it, it can show you what are the contributing factors, and you can see the trend of those. So this way, predictive asset intelligence can satisfy to the needs of various personas in the plant, be it plant manager, be it a maintenance engineer, or a data scientist, or a subject matter expert. So with that, now further, with the help of generative AI Copilot, the end user, such as maintenance engineer or a plant manager, can interact with application in their natural language to understand their asset performance, to compare their assets across the plants, to investigate the alerts, or to perform scenario planning to get best performance out of their assets. And all of this can be done with just a few clicks from user, without the need to navigate through the application. So for example, here I'm showing you a Copilot. So let me kind of launch it. So the Copilot is here. You launch it like this. You usually get prompts, or you can write your own question here. For example, I'm saying list all the anomaly detection alerts for this particular asset during this period, and then I get the list of a list of alerts here. Then you can say perform detailed analysis of alert for a alert number 651, let's say. So this Copilot then look into the database. It kind of combines all the information that is available, and it gives you a summary of the analysis of why that alert is occurring. What is the alert ID, when it happened, what are recommendations, cause, what are the contributing factors, and so on. Now, we have also integrated predictive AI models, forecasting models with this Copilot. So you can also ask for on-demand plot of any particular parameter, or a forecast of any particular channel. And once you have done your investigation on this, or you've done your planning on this, you can simply click on this PDF button here to generate a report to generate the report of this analysis. So this is how this generative AI Copilot can help your people to boost their productivity by otherwise any investigation of an alert, preparing a report might take few hours of a maintenance engineer's time. While here, this can be done in 10 minutes by just writing your questions in natural language. Now, let's look at quickly under the hood of at Iris Foundry that powers our predictive and generative AI solution. So whatever you saw till now is powered by this Iris Foundry, where user can find all the capabilities related to ingesting the data, creating asset hierarchy, modeling the data, extracting the knowledge, converting this data into the knowledge, and then providing value to the end user with insights to reduce, let's say, their unplanned outages, to optimize their processes, and to increase the production. It also provides data governance capabilities to manage complete life cycle of your data. Now I'm going to show you one special feature of Iris Foundry, which is called knowledge graph. Now, what is a knowledge graph? So knowledge graph is basically a visual representation of your all unstructured and structured data that has been contextualized to show how asset, sensors, systems or subsystems and everything connects with each other in the plant. So here each node represent a particular asset. For example, here this is your enterprise level node. From here there it connects to 3 plants which are like these are the 3 plants, and then it connects to the asset in the plant and so on. On clicking of any of this, you can it will show you a dashboard on the right, which will show health score of the asset. It will show some alert summary and so on. If you want to search for a particular asset, you can say select from here, and it will open up that. You can also see the documents which are available for that particular report, for that particular asset. So these are like vibration reports are available here. Some performance curves are available here and so on. You can also see what are the different sensors which are installed on that particular asset. What is the health of those sensors? How many of them are working? How many of them are not working? So this could become a one-stop shop for getting the information of all your assets in the field. Whether it is a sensor data, whether it is a process data, whether it is a structured, unstructured data, whether it is your oil report, everything you can find in one place and analyze it. You can also look at what are the different similar assets which are there in the plant, and I want to see, let's say I want to compare their performance. So there are two boiler feed pumps in my plant, and I want to see how they are working. So I can use this comparison feature here to compare their performance, and I can, if I want, I can create a report to present it to the leadership. Now now all this however, now all this works on a contextualization layer. But before we can even contextualize the data, contextualizing the data means giving the meaning to the data, assigning it to a certain asset and all. But before we can do that, we need to create an asset hierarchy, right? And Iris Foundry gives you an offer for any large manufacturing plant. Creating an asset hierarchy can quite be a Herculean task. There are like hundreds of assets and hundreds of tags and hundreds of sensors, and creating manually asset hierarchy, which will be a digital representation of your plant, is a Herculean task, and it might take a lot of time. However, we have a solution for that. We have a what do you call PNID ingesters. So PNID is nothing but a diagram of the plant which shows how various assets are connected to each other, how they are arranged, what are the different sensor tags are on the particular asset. So we can use a digital represent a PNG file or a PDF file of any PNID, and use the PNID ingester to simply extract all the information at a click of a button. So there are state-of-the-art vision algorithms which are running in the back to scan this document. Right now, I have selected only one, but you can upload multiple PNIDs to scan these PNIDs. And here you can see that algorithm has correctly identified that all these entities which are in the purple box are assets, and all the entities which are in the blue box are the tags. So you can see that for this particular asset, these are the tags which are mapped onto this particular asset. And now you can download this mapping, which will give you a complete a mapping of what are all the tags which are there on that particular asset, if it's a pump or a motor or anything. So just give me a second. Yeah. Now, once you have this mapping, you can go and create this asset in this predictive asset intelligence. What does it mean? That you will have to create a representation of it, and you don't have to worry, you don't have to do it manually. We already have templates for all the commonly occurring industrial assets, for example, centrifugal compressor, pump, gearbox, heat exchanger, steam turbines, motors, and so on. What these templates do is they predefine the information that is expected for a given asset or a piece of equipment. So here for a centrifugal compressor, you can see that this is the centrifugal compressor. These are the channels, or these are the sensor data which is needed for a centrifugal compressor. Not all the data is needed. If all the data is there, which is good, you can cover more faults. However, if only a portion of this sensor data is available, that is also fine. We can still use that to cover a certain percentage of your faults. With this, you can create an asset quickly for your purpose, and then you can use other features to create asset hierarchy, which we saw on the dashboard in the beginning. So you can create an asset hierarchy like this, and you can also then map all the tags or all your sensors to your different assets. And so here you can see that these are all the tags from Historian, and they are all mapped to different assets in the asset hierarchy. So now that we have your asset structure and have populated asset templates, we can the knowledge graph will automatically get created, and it will provide the digital representation of your facility. I would also like to show you one last thing. As I mentioned from the beginning, we have FMEAs. So you can see an example of an FMEA. So here you have like a cause, and you have what is the mode, failure mode. You have an RPN number. You can also have what are all the sensors which are used to map to this cause. What are the recommendations? And so this whole FMEA template is all pre-built into this application. If you want, we can build one for you. If you don't find your asset here, we can build one for you, or we can work with your SMEs to build one. So this data foundation is how we can simplify the effort required to scale your asset performance, to prevent unplanned outages, to optimize processes, and to at the end boost productivity. So I will just end my presentation with one last slide. If you are interested in the solution, you can get an experience of it in a boot camp. We can arrange a boot camp for you where you can get hands-on experience with our application. We will use your data. We will connect to your data. We will create asset structure for your assets, and we will apply a solution on the go to show you the value. You can further access those solutions for 1 week, and uh, uh, carve a path for broader deployment and training. So with that, that's all from my end. Over to you, Frederick.
Yes, Vaibhav, thank you so much. Very interesting, very impressive. And I propose first that, let's say, the participants comes with their questions. Any questions from the audience, please?
I have a question.
Yes, yeah, please go ahead.
Hey to everyone. Hello to everyone. As I work in a company that our data is confidential, I want to know how you can ensure the confidentiality of our data, and where is the calculation resource, so that we can be sure that we don't have any cybersecurity danger or something like that.
Yeah, okay. So there are two ways we can implement this solution. One is we can implement in the cloud. So we use Azure Cloud to implement the solution, where we will create a tenant specifically for your data. Only you will have access to that to that tenant, and we have all security features implemented in that. Another way, if you still not convinced, we can implement this solution on premise. So we can implement on your in your facility this solution, where you will have access to this data to ensure that there is no breach in the security.
So we have to, for example, buy some hardwares that you can implement and your algorithms locally.
If yes, if you are interested in implementing this locally, yes.
Okay, thanks a lot.
Okay. Any other question from the audience? Okay. There is one from Thomas. Tell me more about detection performances, benchmark where other methods could compare. So this is in the chat. Webav, you have also access to that question. Can you answer to Thomas?
Yeah, so yeah, okay, yeah, I see in the chat. So yes, so we continuously measure the false positives with our how many false positives are coming up with the algorithms. How it happens is that first time when we implement this solution, usually there are some false positives, but we continuously work with our SMEs or our connections in the plant to retrain the models, continuously. Most of the time, these false positives come because sometimes there are seasonal changes, which impact the performance of the plant. In case if let's say it's a power production plant, then the how your ambient temperature and all will humidity and all will change the performance. So if the model is not trained uh, on a data which takes into account those seasonal changes, so you might get some false alerts or false positives. So we work continuously with SMEs from the plant to train the model. Once those all factors are accounted for, our strike rate is pretty good. It is upward of 80%. So which is very good for predictive AI models here.
Okay, then Talay in the chat, to implement this software, is it required to have all information in that digital format? In case of very old plant where a lot of information are missing, can we still implement this software?
So, well, it's a very broad question. Maybe if Tala, if you can speak on here to give me an idea on exactly what information you're talking about, which is missing and not available in digital format. Maybe I can address that question better.
Yeah, so like in one of our plant, so it's a very old plant, like built in 1960. So we don't have like a mechanical data sheets. We have just only a page of PNIDs, and that's all. So what can we do?
So if you have paper PNIDs, that's okay. We can always scan those PNIDs, create the PDFs, right? And we can use them in our Iris Foundry to extract the information. So it's not a blocker. Only thing what you need to do is to convert. And I'm not saying convert them into digital format. I'm just saying that scan them and get a PDF from those paper PNIDs, and we can use them.
Oh, okay.
Yeah, you don't need to go to AutoCAD and or other software to really create a new PNID. No, it's pretty simple.
I see.
Yeah.
Thank you.
Okay. In the case, this is coming again from Kiar, in the case of implement the algorithm locally, is the Copilot available and is the algorithm follow an online learning?
So Copilot can still be available because Copilot is only, so these large language models will be trained on your data. It will be looking into your data. This Copilot will not go all over the internet to give you the answer. It will be very specific to your data, which is there in the system. So yes, we can implement this Copilot on premise also. There is no issues. It will not be really going on internet, or it will not be connecting to internet to get you the answers. This is all your data. If it is available locally, we can run Copilot locally. No worries.
Okay, and as we have lots of representatives from the motor industry also, so how easy it is to adapt this solution to assets in different industries?
Yes. So our solution AI algorithms are asset agnostic. in a sense, it does not. We don't have to go and change the algorithms from one more type of motor to another type of motor. What changes are two things. One, the data, because if you have a data coming from steam turbine and coming from gas turbine, those will be different. So the data will change, which will be used to train those algorithms. And second thing, what will change is the failure mode and effect analysis sheet. We have a sheet for some assets which cover all the generic failure modes. But if your particular asset is not there, or the make and manufacturer is different, and we need to include more failure modes in that, we can always do that. We can work with your SMEs to expand that failure mode and effect analysis and include all the failure modes that you want to be there, want them to be there, along with the recommendations. So yeah, so in a way, our solutions are not AI algorithms don't change because the asset is changing.
Okay, and there's an interesting question from Haider. Can you elaborate more on the failure models? Is it
so it is,
or
yeah.
Is it, yeah, you see the question. So do you want me to continue to read it, or you have, because I see that you got already the point, so please go ahead.
I read it, and I guess the answer is similar to what I said. We have some pre-configured assets and FMEAs, and they cover most of the generic failure modes. However, if you have a specific asset and your failure modes are not there, we can always expand those FMEAs. We can always update FMEAs. They are not set in stone. They are fully configurable. We can work with you. Our SMEs can work with your SMEs, and they can, to modify those FMEAs according to your needs.
Okay. Any other questions from the audience? So how long does it take to get this solution deployed?
So yeah, a good question. So usually we start with a a POV, or that is a proof of value, or a POC, proof of concept. So usually we suggest our customers to select 4 to 5 their critical assets, and the assets which have good historical data. And we implement our solution on those 4 to 5 critical assets. It just takes 4 to 6 weeks to implement those solutions. And then they can use it for a few weeks to see how it is working. Once they are happy with the POV, or proof of value, we can then expand it to or roll it out for their large number of assets, or for a plant. And that will depend on how many number of assets are there, how many sensors are there. But to start with, in 4 to 6 weeks, you can start evaluating the value for at least your 4 to 5 critical assets.
Okay. And maybe you can also develop a little bit about what kind of info and resources needed from customers' side to get this solution deployed. So
yeah, so from customer side, we need so from information point of view, as I mentioned, we need they need to identify a use case. We can always help them with that. They need to find out a good use case, and the assets which have a good data, historical data, so that we can train our models there. And we need to work with their SMEs to fine tune the FMES for their asset. That is all what we need from there in terms of information. In terms of resources, if they are going to use or implement the solution on cloud, then we don't need any resources from them. But in case they want to implement it on-prem, then there will be need of hardware on which these solutions can be implemented. Other than that, we need some little help from their IT department to coordinate the efforts. But that's all we need from customer side.
okay. And how do you update the knowledge graph with new information or changes over time?
So knowledge graph is automatically updated as and when you add new asset in the asset hierarchy. There is no manual intervention there. you get a new pump today in the plant, you add it in the asset hierarchy, and it will start reflecting in the knowledge graph automatically.
Okay, and Ida is coming with another interesting question. Does the system support continuous monitoring, or a reading should be entered manually in periods?
No, it supports continuous monitoring. So if sensor data, if we are receiving the data in real time continuously, models will run continuously in the background to give you the alerts and alarms.
Good. So we try to keep our schedule, and there's just maximum 5 minutes, and if we don't need, because I think we had already lots of info and so on. So I'm asking, is there any last question that the audience would like to ask to Vaibhav, please?
Oh, sorry. I have to correct my question that I asked. I mean by online learning, I mean continuous learning. Uh, is it possible that all your model continue to learning during the with new data, or we have to stop sometimes for do and maintenance for the application?
No, you don't have to stop the application. What we do is we retrain the models. So your already one model is running, it doesn't stop. You just have to retrain, make a copy of that model, retrain it on a new data, and then deploy the new model. And the old model will stop, stop working. So there is no break, or you don't have to stop everything and redo everything. It doesn't happen online, like it doesn't retrain by itself, but retraining process does not stop the anomaly detection. You just retrain second model and deploy it immediately.